Welcome for one more lesson. In today's lesson, I'll be showing you the distance of the molecules in solids. That's part of microfluids, which is one of the chapters of fluid dynamics or mechanical fluids. Okay, so let's go. So the distance of molecules in solids, I've designed here some kind of a solid. Intuitively, we can say the distance in solids are much more closer than in water and in gases. I've done the calculation before. If you didn't see it, you can go back to the previous videos and you will see the computation of the distance of molecules or atoms in liquids and gases. Now it's for solids. Okay. For solids, actually, we have to see. We'll choose a Cooper for our calculation. Okay, for our calculation, which we're saying here that there is carbon and U, which is uranium. That is C, uranium. Okay, and the molar mass of Cooper is actually 6354 grams per mole. That's the molar mass of Cooper. Okay, and you can see as well that the mass density of Cooper is equal to 896 times 10 to the power of 3 kilogram meters cubic. Okay, and the Avogadro number, or that's a constant. We can find it in tables that were already measured in the laboratory. It's equal to 23 moles minus 1. Yeah, and we know the number of moles per each meter cubic can be obtained by number of moles per each meter cubic is mass density of the Cooper over the molar mass. And if we do this calculation, we'll find 8 and 6 times over 3, 63, 64 times 10 minus 3. Okay, and here to better know that the unities, we have to do a kind of this, and we'll find that moles meter cubic, that's the unity of number of moles per each meter cubic. If you compute this, then we'll find out that the value of number of moles per meter cubic is 141 times 10 to the power of 5 mole meter cubic. Okay, and from this we have to find out as well number of atoms per each meter cubic, and for this we have to calculate the N, which is the number of atoms, not molecules. That's number of molecules, and now number of atoms per each meter cubic, which will be number of moles per each meter cubic times the Avogadro number, and then the value should be the multiplication of this number, Avogadro number, to term of 23, that's 23 times 141 times that's mole meter cubic times moles minus 1. Okay, and that will give us 8.5 10 to the power 28 atoms per each meter cube. That's the value of the atoms per each meter cube. Okay. Then we have to find out the volume per each atom. Okay, we have to find out one atom occupies which volume. Okay, and let's say volume per each atom should be given by you can say atomic volume is equal to 1 atom times number of atoms per each meter cubic. Then it should give us a number equivalent to this 28, and this is approximately 118 times 10 to the power minus 29 meters cubic. That means that atomic volume or one atoms occupy a volume of this number. Okay, 118 times 10 to the power of minus 29 meter cubic. And from this, we know that volume is equal to something. Let's call it x, the power of 3. Okay, and that x, the distance we are looking for, is equal to actually the square root square of the atomic volume, and it will give us a number approximately to 3 times 10 minus 10 meters, which is equivalent 0.23 nanometers. Okay. Okay, that's it. Okay, so that's the distance distance in solid. We've seen that that's a quick summary with the previous video as well, that in water that distance is equivalent to, actually I think we can find here 310 nanometers. Let's say 310 nanometers, and in gases, perfect gas, the distance is equivalent 344 nanometers. That is 344 nanometers, and in solid that distance is equivalent to 0.23 nanometers. Okay, which intuitively we can find that is true. In water, the molecules are much more greater distance than in gases and solids, and in gases, the molecules are much more, the distance in the gases are much more higher than in liquid in solids, and in solids the molecules or atoms are much more closer. That's why we have something which is solid. Okay, so that's the end of our lesson for today. Thank you. I hope to see you again.